go to YouTube real quick so I can see if it's kicking in. Okay, there it is. It's kicking in. Okay, go back to. Now I will get Rumble and my YouTube started up. And then once that happens, I'll do a countdown. I'll hit I'll do a countdown, hit record, and like I said, let me open up with the introduction for you, and we'll go from there. Okay.
Okay.
So here we go. 3, 2, 1. Now. Good evening, everyone, and welcome to the show. Thanks for joining us, whether you're watching live or chatting or catching the replay later. Tonight, we'll be discussing several topics that Robert has been looking forward to sharing. We'll take them one at a time, giving each topic the attention it deserves before moving on to the next. If you're new to the channel, we're glad you're here, and we hope you'll enjoy the conversation. Now, here's my brother and tonight's host, Robert Hanson.
Thank you, everyone. Thank you, Roger. And to fully understand the conversation, and what better way is that about volcanoes and different types of volcanoes, and where the materials, how each one acts different from one another, and how the volcano material is separate through each one.
You've set me up with a list of volcanoes that you wanted me to read off to you. You want me to start out with the first one? And
yeah,
I can do each volcano one at a time. That way, you give you enough time to talk about each of them. Okay.
Okay.
So this first one is called El Dueña Lungai volcano, and it's probably the weirdest volcano on Earth. It is the only active volcano in the world that erupts cool black lava. The local Maasai people call it Odinyo Lungai, which literally translates to the mountain of God. Because of the weird chemical setup, the black lava turns stark white within hours or days of hitting the air, making the peak look like it's covered in snow. Now, I went and I dug deeper to figure out the name of the volcano and the lore behind it. And I wanted to read that to you too, so that we can kind of get that in here as well. The name comes from the traditional mythology of the Maasai people, who believe the volcano is the physical home of their supreme creator god, Ngai, also spelled Nagai. Now, according to Maasai folklore, Ngai did not always live on top of the volcano. The original home of Ngai originally Ngai lived among the humans on the earth and walked freely with them, providing rain, cattle, and blessings. The peace was broken when a human hunter committed a terrible sin. Depending on the version of the myth, a hunter tried to shoot a sacred bird or accidentally shot an arrow directly at Ngai. Now, offended, hurt and angered by humanity's disrespect, Ingai severed the close connection with humans and returned to the heavens. To remain somewhat close to the earth while staying far away from human reach, Ingai chose the highest, most imposing peak in the region, the summit of Old Duyo Lungai, as a permanent earthly home. Now, because the mountain is Ingai's home, the Messiah read it actively like a direct status report from God. The low rumbling and tremors that shake the ground are believed to be the literal voice of Ingai. Now, when the volcano has violent explosive eruptions that send dark ash clouds into the sky, it is seen as a sign that Ingai is angry with humanity, often due to a lack of respect, war, or broken traditions. Now, when the volcano erupts its gentle, flowing black lava, it is seen as a blessing. The ash from these eruptions is incredibly rich in minerals, which create super fertile soil for grass to grow, feeding the Musai's highly prized cattle. Now, this isn't just an ancient myth either. It is still actively practiced today. The Musai regularly make pilgrimages up the steep slope of the volcano. Tribal elders and women facing fertility issues will climb to the base or summit to pray, sing songs, and offer sacrifices like sheep or milk to Ingai, asking for rain, healthy children, and protection for their livestock. Now, after that, it gets into the crazy cool lava. Now, it's considered ice code for a volcano. Normal lava glows bright red and sits at over 2,000 Fahrenheit or 1,000 Celsius. But this lava erupts at just 1,000 degrees Fahrenheit, which is 540 degrees Celsius. It has the lowest viscosity of any lava on Earth, meaning it flows like water or liquid mud instead of slow, sticky sludge. During the day, it looks like churning black oil or liquid asphalt and doesn't even glow in the daylight. You can only see a faint, dull red glow at night. Instead of being made of silica, which is like glass, it is full of carbonate minerals, basically making it a giant boiling baking soda volcano. Now, the weird chemical setup comes down to one missing ingredient and two very rare minerals. Almost every volcano on Earth erupts silicate lava, which is mostly made of silicone and oxygen, basically melted glass or quartz. Oldoyo Langai has almost zero silica. Instead, it erupts natrocarbonatite lava, which is packed with carbon, sodium, and potassium, making it closer to boiling of laundry detergent or baking soda than actual rock. So, two specific chemical properties explain why it acts and looks so strange. Why it is black, the cold melt. Now, the magic minerals that go into this is the lava is dominated by two incredibly rare minerals found almost nowhere else on Earth. And that's Gregorite and Nererite, low melting silicate rocks. Well, no, actually, silicate rocks need to get blindly hot over 2,000 degrees Fahrenheit or 1,000 degrees Celsius, like I said, before they finally melt and glow bright red or orange. But sodium and potassium carbonates melt at just 1,000 degrees Fahrenheit or 540 degrees Celsius. And like I said, there's no glow in daylight because 1,000 degrees Fahrenheit is relatively cold for magma. The molecules aren't energized enough to emit bright, visible light. In the day.
I was wondering, the two that you were talking about, the two that it's only there, the minerals.
Mm-hmm.
What was the wide variety of uses of that type if someone was wanting to find it?
Well, they're incredibly rare minerals, found almost nowhere else on Earth except for in that location.
Okay, cause like so you could use that too, couldn't you, for medical or for plants growing?
Well, I mean, I didn't really dive deep into exactly what it can be used for. I know that that's why it causes a strange effect in the volcano and stuff.
Well, I was wondering too if it was getting harder to have any odor.
It's basically like boiling laundry detergent or baking soda, which I just read right there. So imagine an entire volcano that is nothing but boiling laundry detergent or baking soda instead of lava.
Okay, yeah. That's why I'm asking. Is if farm animals and grass and wheat and all that's good is able to be used for, it has to have some kind of process within it to work with the plants and farm animals.
Well, they said that it helps them with their prize cattle too, didn't it?
Yeah, I think so. But yeah, but I mean them two minerals too, because since that's all there.
Yeah, it says it creates super fertile soil for grass to grow, feeding them Maasai's highly prized cattle. So yeah, it's incredibly rich in minerals. The ash from this eruption is incredibly rich in minerals, which creates super fertile soil for grass to grow, feeding the Maasai's highly prized cattle.
When it comes to minerals, I was wondering, what kind of minerals is it compared to what regular soil would be like?
Well, I just told you that you're going in a loop. I just I mean that's what it is.
Okay.
It's
Well, I mean, if you was to have some of that shipped over here, mixed in with regular soil, how would it increase the regular soil?
I don't know about all that. Like, I'm just focused. Like I said, all I did is I just focused on the volcanoes and stuff.
Yeah.
You know what I mean? I'm not.
Next one, right? Yeah.
Now, do you want me to finish with why it turns snow white?
Yeah.
Okay. No. The chemicals, gregorite and nerorite, are anhydrous, meaning they contain absolute zero water in their chemical structures. Now, the moment this liquid rock hits the open air, the sodium and potassium greedily reacts with moisture, water, and vapor, and oxygen in the atmosphere. Now, this rapid chemical reaction forces the dark minerals to morph into new hybrid minerals like thermonotrite, and trona within just a few hours to a couple of days. The black rock completely bleaches, breaking down into a brilliant chalky white powder. So it also goes into it actually creates like a sort of alien environment as well, which is kind of cool. The surrounding area next to Lake Natron looks like a sci-fi movie, basically. The ash from the volcano turns nearby soil highly alkaline, creating a brutal environment where very few things can survive.
Alkaline. I heard it's like from out like in Florida, and the bad taste in water you drink.
Mm-hmm.
Okay.
Now it sits right next to Lake Natron, and a lake so caustic it can burn the skin off animals, but it is also the ultimate breeding ground for millions of bright pink flamingos. Interesting. Now the silver volcano is interesting. Now, if it rains in the fresh white lava, it dissolves quickly, turning into a silvery gray sludge. Now, hiking in it is like a nightmare because the ground is made of crumbly ash. It is incredibly steep, and there is absolutely no shade from the African sun. So there you go. It's interesting.
Yep.
That's all of it. Well, could you imagine trying to hike on that thing?
Yeah, man, that would not be pleasant. And to have that water the way it is and all that as well, breathing it in.
Mm-hmm. Yeah, nitron. I've actually heard the term nitron being used before. Maybe later on I can go and check it out because they've also mentioned thermonatrite and trona, which is two more chemicals, new hydrated minerals like hydrated minerals like thermon. I'm gonna have a hard time. THERMONATRITE. Thermonatrite and trona. So that's interesting. I think that was.
Yeah, and considering that water, the minerals there, if it works, so all three of them in an area, because that helps with the plants too.
Mm-hmm.
And livestock, because don't that supposed to help? We call put certain minerals in the body.
Well, they do say that it's got a lot of extra minerals. It helps the grass grow.
Yeah.
So, I mean, I'm pretty sure that's probably got to do with a lot of the chemicals and minerals that are coming up out of the volcanoes. So, yeah.
Okay.
So if you want, I can go on to the next one, which is it's the Sakurajima volcano. That's the second one that you had me look at, and it's Sakurajima is one of the most active volcanoes in the world and a literal ticking time bomb in Japan. It's located right across the bay from the major city of Kokushima on the island of Kyushu. This volcano erupts almost every single day. It is famous for short, sudden explosions that shoot giant ash clouds into the sky and drop volcanic dust over nearby towns. Now, Sakurajima has been in a state of near continuous eruption since 1955. It undergoes hundreds of small to medium explosions every year. Eruptions are so common that the local weather forecast in Kokushima includes a volcanic ash advisory. It tells citizens which way the wind is blowing so they know if they need to grab an umbrella for the ash rain. The city distributes special yellow trash bags specifically for collecting volcanic ash. Residents regularly sweep ash off their doorsteps, put it in the yellow bags, and leave it on the curb for the city to pick up. The 1914 mega blast that happened in Tsukijima used to be is one of the things I found out is the island that became a peninsula is what I found here, and it concerns the 1914 mega blast. Sakurajima used to be an isolated island in the middle of a bay, but in 1914 it unleashed the biggest volcano eruption Japan saw in the 20th century. The volcano spewed out so much liquid lava that it completely filled the deep sea strait separating the island from the mainland. The lava hardened into a solid bridge of land, permanently turning the island into a peninsula. Sakurajima is one of the best places on Earth to see volcanic lightning, too. When the volcano explodes, millions of tiny particles of ash and rock smash into each other at high speeds in the air. This friction creates massive amounts of static electricity inside the ash plume, causing terrifying, beautiful bolts of lightning to shoot out right from the mouth of the crater. Scientists actively monitor the magma chamber deep beneath the volcano. They estimate that the magma supply is already back up to around 90% of what it was before the catastrophic 1914 eruption. Another massive landscape-altering explosion is highly expected in the coming decades. Over 600,000 people live just 4 kilometers, which is 2.5 miles away from this active crater. Because of the danger, children wear hard hats to school to protect against falling rocks. And the city runs massive mandatory evacuation drills every single year. Imagine living in a city where you don't just check the sky for rain, you check it to see if rock powder is going to melt your car's paint. Living next to Tsukijima is like having a giant angry neighbor who drops soot on your porch every morning, but you can't move because the view is too pretty.
Yeah. So they're saying the material that comes from it, when it does, it has electrical, like positive and negative neutrons in it,
Mm-hmm.
and it has its own
Yeah.
field.
Yeah, it says
But I wonder how does it when that does happen? How does the weather does it increase weather? or decrease it? I wonder.
Well, I know that from what I'm taking from it, I just looked at like the actual reaction. You know what I'm saying? Like, basically, when the volcano explodes, like all these little tiny particles of ash and rock are all smashing into each other, and they're doing it at real high speeds. You know what I mean?
Yeah.
And that causes friction, and that creates electricity.
I wonder how far is the radius of when that happens. How far does it go out and still shoots what the electrical and all that? And if you have any problems with their own electric, with all that power surges.
Mm-hmm. Well, I've always noticed that. Well, not always. Later on in my life, I've noticed like you'll see a lot of videos whenever there's an active volcano. They'll show like electricity or thunder over the top of these things. Man, they're always doing it, and it's always fascinated me.
Yeah, what happens to the salt water if there's any salt water around there? You always hear you want to make a battery, the salt water is like battery itself.
I mean, you're just kind of overthinking all that. It's like you know what I mean? It's like we're here to talk about like volcanoes and stuff, and you're talking about car batteries and how it deals with the lake around the freaking volcano and stuff.
Well, I was just wondering when the electric and all that's going on, what is it around like that? How, if you're there at that point in time?
Well, have you actually heard of it? Yeah. So I mean, it's like, I mean, I don't even know if that stuff even actually happened. You know what I mean?
I was just curious because
I mean, you don't expect me to actually try to look for that, do you? I mean, because I mean, for me, it's a pretty dangerous situation in the first place. You know what I mean? It's like I wouldn't really even care about if it's like a volcano's getting ready to erupt, and I'm gonna freaking find out if there's electricity coming out of the lake. Nah, I don't think so.
No, not out of the lake. I was just referring to like if the fish and all that, how, or does it? You can see like electrical shoot from the volcano to the water.
I've never seen that before. I've always seen it popping up out of the top of the volcanoes and right around there, so it was kind of interesting when I seen this talking about like the little particles that are coming from the rock and the ash inside of it, rather than there being like some kind of atmospheric thing going on. You know what I mean? Because that's what I actually figured it was. Like it was, electromagnetism in the air, isn't it?
I guess people should pay attention to the animals on that landmass right there, because they say that the field tells animals when to run and leave because of danger.
Mm-hmm.
But electric. What other type of does having type of other minerals within it?
No, this doesn't really get much into the minerals. The first volcano was more mineral focused. You know what I mean? Because that's actually like imagine a volcano with hot boiling laundry detergent or baking soda. That's pretty interesting, especially considering like whenever kids go to school and do their science projects, what do they always use for lava?
Yeah.
You know what I mean? Baking soda. And they've actually got like a huge, real sized volcano that spews out freaking like laundry detergent kind of materials and baking soda. That's pretty.
I seen on there on one of the videos a picture of it. It looked like a funnel, but it's got electrical discharge going through around it as well, like a tornado inside of from the volcano. Now that is unique.
Yeah. And I did pull up stuff for you when it comes to the rainbows and things of that nature. So we do have that. Some talking points and everything on that. I do want to let you know that.
Oh, okay.
So you want me to move on to the next volcano? Okay, this one is called Kawaiiji volcano. Kawaiiji is an active volcano complex in East Java, Indonesia, and it is globally famous for producing what looks like glowing neon blue lava at night and housing a massive summit crater lake made of pure battery acid. And this is probably the one you were talking about before when it comes to the neon blue, the blue lava.
Yeah, and I've seen the video of it too, where that little water area off to the side. I forget what they call it, pH, or well, it's as high as any battery solution is. And they were showing it's strong enough to literally just chew you up if you get into that water.
Mm-hmm.
And people that collect that material, they lose their teeth. They do their front teeth, even with that mask around them.
Mm-hmm.
They breathe it, and that fabric still don't keep the material from getting into them.
Well, it's like if you have a chance, okay, to look at that picture again, and you think that that's blue lava, okay, think again. There's a plot twist to that. It isn't lava at all. Okay, the volcano is packed with massive amounts of sulfur, and that basically high pressure, super hot sulfuric gases. That's over freaking 1100 degrees Fahrenheit, 600 degrees Celsius, leaks out of the cracks of the rock. Okay. The second these gases hit the oxygen rich air, they ignite and burn with an electric neon blue flame.
Electric neon?
Electric neon blue flame.
That's with like gas.
No, imagine Tron, dude. Like all the blue and the red everywhere.
Oh, yeah. Yeah, but what I was trying to is it's like gas, and when it hits the atmosphere, it turns into that.
Blue flame.
Oh, okay.
Imagine a neon blue flame. You know what I mean?
Yeah.
Now, the burning sulfur gas is so intense that some of it condenses into a liquid while still on fire. Then it flows down the side of the mountain like a glowing blue river, perfectly mimicking molten lava in the pitch black. So basically, it's the world's largest acid barrel. Now, inside the volcano sits a turquoise green crater lake. Do not let the pretty colors fool you, though. It is the world's largest hyper acidic lake. The water is fed by volcanic gas that turn the lake into a concentrated soup of hydrochloric and sulfuric acids. The pH levels is close to zero, meaning it has the same acidity as car battery acid and is strong enough to dissolve metal or a human body in a short amount of time. You think about that.
Yeah. And What's the temperature for anything to get that hot? They say different colors for a different temperature,
Hmm.
and for it to be blue flame, that would have to be pretty hot, wouldn't it?
It says that it's super hot sulfuric gases that's over 1100 degrees Fahrenheit, and that's also 600 degrees Celsius.
Okay.
So yeah, you're looking at some weird stuff. And then they also have another nickname for it, the Devil's Gold Miners. There's a thing thing. There's a local artisanal miners who climb down into this toxic abyss every single day, and it's considered the most brutal job on Earth. The miners use ceramic pipes to trap the sulfuric acid, cooling it down until it hardens into bright yellow solid sulfur crusts, which locals call devil's gold. Without heavy machinery, these miners break the sulfur with crowbars, pack it into bamboo baskets, and carry loads weighing 160 to 200 pounds, which is 75 to 90 kilograms, on their shoulders out of the steep crater rim. They often do this while breathing in choking toxic sulfur dioxide smoke.
I wonder how. Okay, I know there is a wide variety of uses, but for what they do, how many companies that deals with that stuff? How many industries, orders that you would think that would have to be a good size chunk of change for someone.
Mm-hmm.
And for to have that much of a use from natural resources, that's good. Instead of having to create it, you can get it from Mother Nature. Which one would be even better, Mother Nature's stuff or where you got to manufacture it?
I see it like this. Think of that volcano like a real life video game dungeon.
Yeah.
By day, it's all beautiful. It's a turquoise, beautiful lake that will like literally melt your armor if you fall in, and then by night, the entire place lights up with magical blue fire like a fantasy boss arena.
Yeah, and they were saying too. At times, people would get they would get paralyzed from the odor, and they would fall down and have to try to recover themselves because they couldn't barely breathe at that time because of the gas from it.
Right. It could easily be like one of the most hostile yet visibly stunning places on the planet. It's pretty interesting from what I've seen from it.
That would be that's high risk too when you stop thinking about
it. Oh hell yeah!
It's
you're not getting freaking any kind of insurance working that job. You might get danger pay just in case something does happen to you, but they're not going to be giving you no freaking health insurance.
That's sure.
Yeah.
Does that stuff will explode too, doesn't it? The gas from it.
Well, I'm pretty sure that that really, breathing in choking toxic sulfur dioxide smoke.
Well, I mean, they have to watch out too, make sure no spark.
Dude, I would never be down there with a freaking lighter or anything like that. You would never catch me down there doing that with a lighter or anything of that nature. So,
yeah. But around that area, they don't have that much of roads. plants I'm referring to.
Mm-hmm. Now, another thing you wanted me to check out is these lahars. Now, do you know what a lahar is?
No.
Okay, so you want me to get on to that?
Yeah.
I can get on to that if you want. Now, a lahar is a violent, fast-moving mudslide or a landslide made of volcanic debris and water that flows down the slopes of a volcano. Think of it like a massive river of liquid concrete rushing down a mountain at highway speed. Now, the word lahar comes from the Indonesian language, which makes sense because Indonesia has many active volcanoes where these happen frequently. Here are some quick, punchy points about lahars that you can easily uh, share with people if you ever come into this conversation. First of all, how are they created? Okay, you only need two things to make a lahar. That's volcanic rock or ash, which is basically the debris, and a lot of water. Now, they are usually triggered by three things. That would be a uh, melting snow would be one, heavy rain, and then crater lakes. Now, a volcano erupts and the hot lava or gas instantly melts glaciers and snow caps at the top of the mountain. Intense rainstorms or typhoons dump water into loose, fresh volcanic ash on the slopes. Or an eruption breaks through a wall of a volcano's crater lake, which ends up spilling millions of gallons of water all at once down the mountain. This is how they're created. So after you get to that, we ask, well, why they're so dangerous. For one thing, they're faster than you. Lahars can travel at speeds of over 40 to 50 miles per hour, which is 60 to 80 kilometers per hour. You cannot outrun them on foot. Also, they grow as they go. As a lahar rushes down a river valley, it traps everything in its path. It swallows builders or boulders, trees, cars, and buildings. Getting bigger, heavier, and more destructive by the second, basically. Then you have the concrete effect. Now, when a lahar stops moving, it doesn't just dry like regular mud because it is full of volcanic ash and minerals. It hardens into solid, heavy rock. Villages caught in the lahar are often buried permanently.
It's like that white stuff that flows down the mountain from the volcano.
Yep.
Oh, okay.
Now, the most famous stream example would be Mount Pinatubo, and that's in 1991, where Mount Pinatubo in the Philippines erupted. Right after the eruption, a massive typhoon or hurricane hit the area. The heavy rain mixed with the fresh ash and created colossal lahars that caused way more damage and destruction to nearby towns than the actual eruption itself, burying entire neighborhoods up to their roofs. So a lahar isn't just muddy water. Imagine a giant blender filled with wet cement, broken trees, and boulders the size of cars dumped down a water slide at 50 miles per hour. It wipes out everything, and when it stops, it turns into solid rock.
Does it say how far Could any of this be airborne? And if so, what would be the difference?
Airborne, Robert.
Well, yeah.
Imagine a landslide of cement.
Yeah, that would not be pleasant. I know that. I'm just saying when it explodes the volcano, and if that stuff's there,
this is separate from the volcano altogether. This isn't even. This is a lahar, which is not even part of the actual volcano eruption.
Oh, okay.
Yeah. So both Sakurajima and Kawatijan have an incredibly high risk of lahars, but they are dangerous for two completely different reasons. Now, one volcano creates regular lahars because it rains constantly, while the other sits on a ticking time bomb of a lahar made entirely of boiling battery acid. Think about that.
Yeah, okay.
They say this Sakurajima is the nonstop mud machine. It deals with rain-triggered lahars on a nearly daily basis. Because Sakurajima erupts multiple times a day, its steep slopes are constantly piled high with loose, fresh volcanic ash. Now, Japan gets heavy rainfall and intense typhoons. When a heavy rainstorm hits Sakurajima, it instantly turns the mountain's loose ash into rushing rivers of cement. So, over 30 lahars a year, basically.
So, like two different types of volcano situations and different types of seasons.
Well, one of them, the one in Japan, okay, it's in just a constant rainy environment. You know what I mean? So every time it rains, it just turns freaking the sides of this volcano into nothing but like a wall of freaking a mudslide of cement, basically. It has over 30 lahars a year. And scientists studying Sakurajima have recorded more than 30 lahars happening every single year on that volcano alone. All right. Now, Japan built massive concrete channels called sabudams down the side of the volcano. These channels capture the mud and redirect it safely into the ocean, keeping the lahars from burying the nearby roads and cities.
Oh, okay.
That's just the Sakurajima that's in Japan.
Okay.
I can tell you about the Kawatijan or Ijan, the acid nightmare lahars.
Yeah.
You're gonna be okay. I don't know if this might make it hard for you to sleep tonight. You want me to go?
Well, that white stuff, when all that just happens, I wonder what is the process of the government for people, or if the stuff gets even worse,
I think with them, the best thing they can do is what they're doing right now is create cauldrons to freaking redirect it into the water. You know what I mean? For me personally, I think if you're living that close to a volcano and you're having to put up with stuff like that, it's time to move. That's a little bit too dangerous for me. So it's just like this next one, the Kawaijan. They literally call this the acid nightmare lahar. because it has a lower daily frequency of lahars, but it presents a catastrophic acid lahar risk if it undergoes a major eruption. 30 million cubic meters of threat, to be precise. So remember that beautiful turquoise lake sitting in the crater. It holds roughly 30 million cubic meters of pure concentrated sulfuric acid. If Kua Ijan has a massive eruption from the bottom of the lake, the explosion could breach or shatter, the crater wall. If that crater wall breaks, the entire lake will drain instantly. Instead of a normal lahar made of water and mud, a massive boiling wall of corrosive acid mud would rush down the mountain valleys. This acid lahar would wipe out local farming villages, poison the region water supply, and dissolve crops and structures across East Java, which is where it's located.
So that would be about 2,000 acres.
I don't know for sure. I don't think they mentioned the amount of distance. I don't think they measured that out. So Sakurajima is like an active construction site that gets flooded every time it rains. And it ends up washing wet cement down the driveway. Now, Kawa Ijan is like a giant beaker, a giant glass beaker filled with like battery acid sitting on the edge of a table. Now, if the volcano shakes too hard, the beaker shatters, and a wave of burning acid floods everywhere below. So, interesting stuff right there.
Yeah. How long will it? If that actually ever happen? No, I'm saying about if there's a crack or anything that got created, or even a small portion of it, that acid like mutates, grows, it expands. Acid does.
Well, I know this is definitely one of the most interesting volcanoes by far. I mean, because this is freaking a wall of battery acid. You know what I'm saying? Like, that is insane. And this is coming from out of the ground, so there's no way of getting rid of it. This is like saying you're going to get rid of freaking lava. It's just.
What I was referring to is that even if a small portion of it, if that where it's at, if it ever cracks or a little bit runs down the thing, it would like just totally destroy everything and grow. More or less, like eating everything, however acid does.
Now, I want to see if you know this. I pulled up the information for you, and I wanted to ask you: do rainbows form because of the lava in erupting volcanoes?
What I've understood is between gas and light particles within the gas makes different layers of colors and thickness of it.
Now, when I looked up this stuff, because this is what you wanted me to ask, I found out that rainbows can form right next to erupting lava, creating some of the most viral and breathtaking natural phenomena caught on camera. However, the lava itself doesn't technically create the rainbow. Instead, rainbow forms an outside moisture like rain or mist, and that passes over the erupting volcano at the exact moment the sun hits it, at a perfect 42-degree angle. Uh, the Hawaii pot of lava eruption in Kilauea is one example. One of the most famous incidents happened at Hawaii's Kilauea volcano during its record-breaking lava fountaining episodes. Now, photographers captured like a stunning, vibrant rainbow, perfectly framing a tower or a towering red-hot lava fountain shooting hundreds of feet into the air. Then there was the lava pot where the U.S. Geological Society shared photos of the event, joking on social media about finding a pot of lava at the end of the rainbow, since the rainbow appeared to drop right into like a massive 700-foot deep boiling lava lake. So you had that one, and then you had Iceland's rainbow eruption illusion along the Snøhvit crater row in Iceland. A perfectly timed rainbow appeared to rise straight out of a volcanic cone. To onlookers, and cameras, it created the jaw-dropping optical illusion that the volcano was violently erupting bright colors inside of molten rock. Then you come to iridescent plumes, the rainbow clouds. And sometimes volcanoes create a different type of rainbow effect high in the sky called cloud iridescence. And this is how it happens. When a volcano blasts an ash plume high into the atmosphere, it pushes moist air upwards, forming unique clouds over the peak. If the sun hits these clouds just right, the tiny ice crystals and microscopic volcanic ash fragments act like millions of tiny glass prisms. They scatter and bend the sunlight, painting shimmering neon rainbow crowns right on top of the dark volcanic smoke. So, we've all heard the myth that there's a pot of gold at the end of the rainbow. But if you visit the erupting volcano in Hawaii or Iceland at the right time, the physics of light will the physics of light will literal updrop a rainbow into a giant cauldron of boiling red hot lava. It turns a scene of pure destruction into a fairy tale landscape.
Yeah, 'cause I've seen some of the pictures where it looked like a tornado within the rainbow.
Mm-hmm.
Yeah, that's quite good. And looks like it's going.
I know whenever I seen you on the computer, you really do enjoy watching those or checking those pictures out and everything.
You know, like that one volcano where they found diamonds in it.
Mm-hmm.
And they cleaned the process of it, and they came across all these diamonds from the volcano. And it makes you wonder, okay, the volcano, the circle where all these volcanoes were hooked together through the thing. Makes you okay. Each one within an area has a way of separating the materials for that specific type of volcano. Because for all the volcano material to be separated into different groups.
Well, I think you're missing the boat on that one. You know, where do you come up with this thing like they're separating stuff within the volcano?
Well, like that one the acid one.
Well, you know, like this
The
is,
ring of fire. They're all connected through that. They are.
they're all connected through uh, cavern that's underneath the earth that tunnels lava directly from the center of our planet, or uh, from the magma all the way up. Lava is nothing but magma from freaking
Core of the earth.
some of it's from the core, but that's even stronger than actual magma. Like we have the crust, and then we have the freaking magma, which is underneath that.
Yeah.
Okay, and it literally comes up. So there's no separating this stuff. You know what I
Well,
mean?
it has some way of absorbing certain materials for certain ones.
Mhm.
However, it does. Because each individual, that's what I'm referring to. For individuals, look at each one, how the process works for that one. And they call it, and how, what I was referring to is they show from Japan, the Ring of Fire, how it goes all the way down to New Zealand.
Mhm.
And like New Zealand, one of the other smaller islands,
Yeah.
they have a volcano there, and it's a good sized one. Like that one that a lot of people got hurt because they were there when it went critical. It was on the news. I seen it on the news from when they were recording it, and they had to rescue the people.
I'll tell you what, you did a pretty good selection of volcanoes to pick for this show today. These were pretty interesting because you always hear about like these horrible volcanoes. You know what I mean? And they're everywhere. Don't get me wrong. And but like you just mentioned, well, the first one was like boiling freaking laundry detergent. The second one was freaking battery acid. You know, a volcano of nothing but battery acid. And then this third one was was well, no, the third one was the acid, wasn't it?
I
Yeah, the second one was electricity.
Yeah.
Yeah.
And then one about the concrete, like the white concrete stuff that comes down with the volcano.
Yeah. That is just something else, man. Let me go ahead and make sure. Yeah, no, Sakurajima was the one that was the battery acid and everything. Yep. And then El Dionia, that one was the one with the chemical acid. And then Sakurajima is the ticking time bomb. It's the one that they talk about with sudden explosions, and it's happening all the time, just daily eruptions. And it turned that island into a peninsula back in 1914.
Oh, yeah.
It reminds me of this island. I remember a few years ago they talked about it, where these people live on this island. They literally have to wear like gas masks just to live in that town, to go out, and they have to have their like, they have to have rubbers on all over them so that freaking they don't, because there's constant ash falling. Can you imagine that?
Yeah. Remember that one? They were talking about this one island anyway, the volcano and all that. It went super, but the center of it fell back into the ocean, fell back, but the center, the outside of it, stayed.
Mm-hmm.
Now that's unique and different all by itself.
Yep.
And but what I was referring to is something has to be there, for each of them to work within its own self for the materials that it does. And they always, what is the ring of fire? How is it the ring of fire works is connected to the other volcano.
No, that actually is a good topic to bring up, but I've ran out of all the talking points that you wanted me to do. Do you think it'd be a good time to go ahead and end the show and maybe come back and do another episode at some other time?
Well, let me just say this.
Okay.
With all the materials and ideals of it's good to know all this in the process, and it's a curious science and how has it affected our weather, because with each of the stuff that happens, how does our climate handle it? Thank you. I'm done.
Okay. So that brings us to the end of tonight's program. We appreciate everyone who stopped by to spend time with us. Even if you're watching this later, thank you for taking the time to join the conversation. If you enjoyed tonight's discussion, we'd appreciate your support by following the channel and sharing the stream with someone who might find it interesting. We'll be back with more conversations and more topics soon. Until then, take care of yourselves and have a great evening. And we'll see you next time. Good night, everybody.